Good morning, students. Students, I'm very happy and I really want to thank you for paying attention in the class all these days and preparing all the three chapters thoroughly and in depth. As I can see from the past few days, from the past 3 days, that during the MCQ test, most of the students have scored above 90 percentile marks and have completed the test in a very short interval of time. But still for the students there were some perplexing questions which made them think whether which option to choose. So in this video I would like to highlight few of the concepts within the short span of time, and the one of the concept was based on uniform circular motion, and there were two questions which were based on it. So in a uniform circular motion, first of all we should understand what is a circular motion. Whenever a body moves along a circular path, such motion is known as a circular motion, and if a body is traveling with a constant speed during that circular motion, that motion will be named as a uniform circular motion. So students, few question arises, and one of the question was a merry-go-round, that means a train or something in a power plant is moving in a circular path of radius r. Okay students, so see, we know that this is the radius. Okay, now suppose from this point towards this point, towards opposite point, the merry-go-round is moving, and they are asking that the displacement of after half a circle would be. That means when the merry-go-round covered a half circle, what will be the displacement? As we know, the displacement is the shortest distance between the initial and the final position. So this is the initial position of the train or the merry-go-round, and this is the final position. So this shortest length, shortest distance, this will be the displacement, which will be 2r. Okay, even there was one question which was asking that in a uniform circular motion whether the speed is constant or the direction is changing, okay, or the velocity is constant. So and the last option was the second one, and the third one is right. That means the speed is constant as well as the direction is changing at every point. This is the right option. So as we know in the figure, we can see that suppose this is a motion of a body in the anti-clockwise direction. At every point, this point the direction is in this direction, so velocity vector is in this direction, now in this direction, now in this direction, and in this direction. Okay, so now in this way we can see that in a circular motion or a uniform circular motion, the direction at every point is changing. So the velocity will also change because the velocity is a vector quantity, and in which the magnitude and direction both are considered. So if the velocity is changing, there will be acceleration. And so if we ask one more question based on uniform circular motion, that whether a body traveling in a circular path have a uniformly accelerated motion. So why it has a uniformly accelerated motion? Because at every point the direction of the direction of the body is changing, and the velocity changing. If the velocity is changing, there will be acceleration. Okay students, in this manner the uniform circular motion is an accelerated motion. Now there were some questions based on equations of motion, and one of the questions was to identify the position time relation. Okay students, so you can see this relation is s equal to ut plus half at square, and there were options like s equal to ut minus half at, or the s equal to ut plus half at, but there should be t square also. So I want to advise you that please pay very utmost attention, and with full attention and concentration watch and read the concepts of the chapter and even the formulas like this. So it is s equal to ut plus half at square, and this is we name these relations as velocity time relation, position time relation, and position velocity relation. So the velocity time relation is v is equal to u plus at, position time relation is s equal to ut plus half at square, and position velocity relation is v square minus u square is equal to 2as. Okay, so these are the certain relations on which there are certain numericals which are based. So I'm not going to present very difficult numericals in front of you, because you must get confused or even terrified with those numericals, as this is an objective test. So numericals will be based on a little bit based on the time. They should be a bit shorter numericals which can be easily solved within a time span. So please consider this point very clearly. So the first numerical will be based on a child made a paper boat which starting from rest on a lake accelerates in a straight line at a constant rate of 3 मीटर पर सेकेंड स्क्वायर for 8 सेकेंड. दैट मीन्स एक बच्चे ने एक पेपर की बोट बनाई है, वो इनिशियली रेस्ट में थी और लेक में वो मूव कर रही है स्ट्रेट लाइन में, और एक्सेलरेशन कितना है उसका 3 मीटर पर सेकेंड स्क्वायर, और टाइम कितना लगा 8 सेकेंड. ओके, कितनी दूर वो बोट गई बच्चे की. ओके, सो इन दिस वे वी कैन सी इनिशियल वेलोसिटी रेस्ट पे तो 0 हो जाएगी, एक्सेलरेशन 3 मीटर पर सेकेंड स्क्वायर है और टाइम कितना है 8 सेकेंड है. सो इन दिस वे वी विल अप्लाई दिस रिलेशन, दैट इज अ पोजीशन टाइम रिलेशन. व्हाई वी आर अप्लाइंग दिस रिलेशन? वी आर अप्लाइंग दिस रिलेशन because in this we have to find out the distance, and this is the only relation in which the position as well as the time is being given. So u is 0, t is 8 half, a is 3 and t is 8 square. So in this manner the distance will come out to be as 96 meter. Okay, now see the next numerical. The next numerical which I gave in the test was while sledging. That means sledging is a certain kind of a game or a way people used to slide down the hill. Okay, you must have performed sledging on a mountain hill. So a child has an acceleration of 2 centimeter per second square. What will be its velocity 3 seconds after the start? Okay, so now the child is sliding down a hill. Now this initial velocity will be 0, its acceleration is 2 centimeter per second square, and the time is 3 seconds. They are asking that what will be his velocity after 3 seconds after the start. So he moved a 3 second distance, so its velocity must have changed because there is an acceleration of 2 centimeters per second square. So in this way the velocity will be v is equal to u plus at. What is u? That is 0, a is 2 and t is 3 seconds. So in this way the velocity will come out to be as 6 centimeter per second. It is centimeter, don't consider as meter because the acceleration is in centimeter. So in this manner the velocity will also be 6 centimeter per second. Okay, so now the next question which is based on the third equation of motion, which we call as position velocity relation, v square minus u square is equal to 2as. So this is the question based on it. Our train is traveling at a speed of 25 meter per second. Okay, now brakes are applied to produce a uniform acceleration of minus 0.5 meter per second square. So in this case initially it is traveling. They are saying the train is traveling, that means the initial velocity will be 25 meter per second, and the brakes are applied to produce a uniform acceleration of minus 0.5 meter per second square. So acceleration is minus 0.5 meter per second square, and this is minus, that means the train is retarding, and the final velocity will be 0 meter per second. So in this way students, we will apply the formula and put the various values in it. So v is equal to 0, u is 25, and a acceleration is minus 0.5, and as well as the distance has to be find out. So the answer will come out to be as 625 meter. Please remember that the acceleration is, the body is retarding, so we'll put the formula as minus 0.5 meter per second square. Okay, so this was a bit small concepts, little bit concepts which I explained on the motion chapter. So even tomorrow I will be taking a class on Google Meet in which I would like to discuss various other concepts. So please attend the class, and if you have any queries you can directly call me. And all the best for your exams, and you can do it. You can perform very well. I believe in you. So students, thank you very much.